We all know the postcard version of California, the beaches, the massive mountain ranges, the forest, the deserts. But everything we're looking at on the surface, it's really just the final page of a massive, incredibly complex story. This land was built and is still being torn down by forces that are actively working right now. Tectonic plates grinding past each other, ancient magma cooling deep underground, massive rivers carving through solid rock. It's not just scenery, it's a living, moving system. And honestly, once you start noticing how it fits together, you stop just looking at the ground, you start reading it. Hey everyone! So, California is one of those unique places where the ground beneath your feet it genuinely doesn't sit still. Now, by that, I don't mean you're going to feel it shaking every single day, though we do get some of those reminders. It's more of a quiet, constant shift over millions of years. And you've probably heard about the big stuff, the San Andreas Fault, the gold rush, or the volcanoes up north. But those are just random moments in a much bigger plot line. What we are going to do here is actually pretty simple. We're just going to learn how to read the landscape. Like when you look at a mountain range or a deep valley on a road trip, instead of just saying, that's pretty, we want to start asking, why is that there? Why is it shaped like that? And what is it currently turning into? Now, once you shift your perspective a bit, you realize geology isn't something abstract in a textbook. It's literally right underneath us. Now, let's just take a quick mental trip across the state because California is split into these distinct geologic provinces and each one has a completely different personality. Take the coast ranges, built and twisted by shifting plate boundaries. Right next to it, you have the Great Valley, this massive basin that used to be completely underwater, trapping layers of sediment and creating the incredible agricultural soil we have today. Then you look east and you hit the Sierra Nevada, this massive block of granite born from ancient magma deep in the earth. Keep moving and the land stretches out into the basin and range or drops into the Mojave Desert, where wind, intense heat and time have laid the bedrock completely bare. Even further north, you hit the Cascades and the Modoc Plateau, where it's all about young volcanoes like Mount Shasta and Lassen. Every single one of these places looks different because they all have a completely different history. When you see that, the map stops being flat. It turns into a story. Over the course of this study, we're going to connect the dots between a lot of moving parts. We look at the fundamental building blocks, minerals, and the three main rock families, igneous, sedimentary, and metamorphic. We'll dive into stratigraphy and geochronology, which is basically the science of dating rocks and figuring out the calendar of the Earth. We'll talk about plate tectonics and structural geology, how rocks bend, fold, and break under massive pressure. And of course, seismology. We look at how faults like the San Andreas actually behave and separate the earthquake myths from the actual science. We'll even look at how all of this shaped human history, like how California's gold and oil resources are directly tied to ancient magmatic intrusions and old marine basins from millions of years ago. The point here isn't to just memorize a bunch of terms for a test. It's about seeing how everything connects. Because when you do, science, history, and geography all start blending together. And look, this isn't the kind of subject where you just sit back, take a bunch of notes, and call it a day. At least not with me. It only really starts clicking when you actually look at the physical world around you. Like seriously, a crack in the sidewalk, a weirdly shaped hill somewhere behind in your neighborhood, a random rock you stumble over in your yard, or even the way muddy water carves out a little channel along the curb after it rains. Every single bit of it is telling you something about how materials behave. So while we go through these chapters, I want to challenge you to stop just watching the videos. Start noticing things in your own neighborhood. That's honestly where real geology begins. Now let's do something simple right now. Sometime today, Just go outside. Walk out your door, look around and find one rock. Don't look for a perfect crystal or something beautiful. Just pick up an ordinary rock. Hold it and actually look at it for a second. Ask yourself a few basic questions. What colors are in it? Is it just one solid color or is it speckled? Does it feel totally smooth like it's been tumbled in water or is it rough and jagged? If you look really closely, you can see distinct layers stacked on top of each other or tiny individual grains sandpapered together. You don't need to know the specific name of it yet. You aren't trying to find the right answer. You're just training your eyes to observe. That's the first thing geologists do. They observe first and then they start asking the right questions. When you pay attention long enough, you start to realize something kind of wild. The earth isn't just this static, finished thing we live on. It is constantly building, breaking down, and entirely reshaping itself. And honestly, California is probably one of the best natural laboratories in the world to watch that happen in real time. We're going to take it one piece at a time. And my hope is that by the time we finish, you won't just know a bit more about geology. You'll actually start seeing it just out there, everywhere you look. The ground has a story to tell, and we're just learning how to read it. So let's get started.